Okay, picture this. You walk into a totally state-of-the-art laboratory today. You've got scientists in white coats, glowing digital displays everywhere, complex glass equipment bubbling away. Now, what if I told you that every single modern medicine created in that lab, every chemical analysis they run, and even the purification processes used in massive heavy industries, what if they all trace their roots back to literally one single pioneer? Sounds kind of impossible, right? I mean, a single point of origin for all of that complexity?
But here is where it gets truly mind-bending. Because that foundational scientific figure, he didn't live 50 years ago. He didn't even live 500 years ago. He lived more than 1,200 years ago. Think about that. At a time when the entire world was basically steeped in mysterious theories and magical thinking, one scholar decided to completely change the rules of the game.
Welcome to The Explainer. Today, we're diving deep into the life and the absolutely immense legacy of Jabir ibn Hayyan. Today, historians all over the globe universally recognize him as the father of chemistry. But how exactly did a guy from the 8th century earn a title that carries so much weight in our modern world? What were his actual concrete contributions? And why on earth are we still using his discoveries 12 centuries later? Well, let's unpack the incredible story of the true architect of experimental chemistry.
Part 1. The World of Alchemy.
Right, so to truly appreciate what Jabir pulled off, we have to understand the world he was actually born into. Because before him, people weren't really practicing science. They were practicing alchemy, which was this wild mix of observation, philosophy, and frankly, a whole lot of superstition. You had alchemists trying to magically turn ordinary metals into gold, or hunting for these mystical elixirs that would supposedly grant eternal life. They genuinely thought mysterious, unseen forces controlled how matter behaved. And sure, while they occasionally stumbled onto something kind of useful, their methods were just chaotic. Nothing was recorded properly, everything was based on wild speculation. But Jabir? He introduced a totally new framework: observation, recorded methods, and a strict evidence-based approach. He essentially replaced magic with a rigorous, practical system.
Part 2. The Experimental Revolution.
And that massive shift, moving from magical assumptions to rigorous proof, it sparked a complete revolution. This quote right here: "This is everything. Don't just believe it, test it." I really want you to let the weight of that sink in for a second. During the 8th century, people basically accepted ideas just because respected older authorities said they were true. But Jabir completely flipped that mindset upside down. He believed that nature follows very specific laws, and you can't just guess what those laws are. You literally have to test them. If you want to know what happens when a substance is heated, or how two materials react when you mix them together, you don't go looking for magic, you observe. That was an incredibly radical, game-changing idea for his time.
So the really crucial point is how he actually put that mantra into practice. He relied on 4 key steps. 1. Conduct the experiment. 2. Record the observations carefully. 3. Verify the results. And 4. Repeat the procedure. These 4 steps were his ultimate weapons against superstition. And what's absolutely stunning about this is that it's the exact same scientific method, the exact same process used in literally every single chemistry laboratory in the world today. He took chemistry from a messy collection of mystical ideas and turned it into a verifiable science that was just waiting to be explored.
Part 3. Inside the first laboratories. So, what did it actually look like to do this back in the 8th century? Jabir didn't just sit at a desk and write out philosophical theories. No, he got his hands dirty. His physical workspace was all about precision work. He was constantly heating, purifying, separating, and analyzing substances. But to do all that, he needed the right tools. So he designed custom equipment specifically for chemical work. And he insisted on absolute precision with really careful measurements because he understood a fundamental truth of chemistry. Even a tiny mistake, like just a fraction of an error in measurement, could completely ruin the results of an experiment.
Part 4. Mastering chemical processes.
By bringing that intense level of precision into the lab, Jabir perfected the techniques that basically define the discipline today. Take distillation, for example. Now, Jabir didn't invent the absolute concept of heating things up, but he vastly improved the process and the equipment used for it, making it incredibly reliable. The definition is straightforward but super powerful. You heat a liquid until it becomes a vapor, and then you cool that vapor down so it converts back into a liquid. Because different substances boil at different temperatures, this allows scientists to perfectly separate and purify them. Jabir made this method highly effective.
Now you might be wondering, why does this actually matter to us right now? Well, think about pharmaceuticals, or water purification, oil refining, even perfume production. Every time you take a manufactured medicine, every time you use purified water or rely on fuel from an oil refinery, you are directly benefiting from the distillation techniques that Jabir helped develop and perfect over 12 centuries ago. He took this ancient science and grounded it into a reality we literally cannot live without today. But distillation was really just the beginning. Let's look at how this builds into another massive breakthrough: crystallization. By controlling conditions perfectly, Jabir figured out how to make pure crystals form out of prepared solutions. Why is that a big deal? Well, because pure substances are vastly easier to study. When a substance is completely pure, you can measure its properties with incredible accuracy and understand exactly how it reacts. To this day, crystallization remains absolutely essential, especially in modern pharmaceutical manufacturing. Jabir also did extensive, highly systematic work on two other fundamental techniques that you'll find in any daily laboratory routine. On one hand, we have evaporation, changing a liquid into vapor to separate out the dissolved substances left behind. And on the other hand, filtration, separating solid particles directly from liquids. He refined and improved these methods so he could study materials more effectively. Now, they might seem like simple high school science class concepts to us today, but that's exactly the point. They are the absolute foundation of chemical analysis, and he was the one who standardized them.
Then there were the phenomena that honestly seemed almost like magic, right up until Jabir applied his scientific lens to them. Take sublimation. This is what happens when a solid changes directly into a gas, completely skipping the liquid phase altogether. This highly unusual behavior totally fascinated Jabir. By heavily researching it, he proved to the world that matter could change in highly predictable ways, if you understood the specific conditions. He was actively expanding human understanding of how chemical transformations actually work.
And as his methods grew more sophisticated, so did his materials. Specifically, he started working with intense mineral acids like nitric and hydrochloric acid. Before Jabir, materials like these were treated as terrifying, mysterious substances, but Jabir shifted that entire paradigm. He didn't treat them as mysteries. Instead, he scientifically documented exactly how they behaved and how they reacted with other elements. These exact acids would go on to become some of the most important substances in all of industrial chemistry. Now, with all these new pure substances, acids, and reactions, Jabir naturally ran into a problem: information overload. His solution to that? Scientific classification. He created strict, organized categories: metals, minerals, salts, compounds. He recognized the truth that all modern scientists know for sure: you cannot effectively study chaos. Before you can understand something, you have to organize it. By classifying chemical substances according to their properties, he brought order to a field that was previously just a confusing mess.
Part 5. A lasting scientific legacy.
Through this relentless experimentation, Jabir built something that outlasted his own lifetime. Because science only advances when knowledge is shared, and Jabir understood this better than anyone else in his era. He essentially created the shared language of chemistry. He meticulously documented his procedures and explained his observations so that future scientists could repeat his experiments and verify his results. Centuries later, these amazingly detailed texts traveled out of the Middle East and were translated into Latin over in Europe, where he became known under the name Geber. His laboratory methods spread like wildfire, deeply influencing generations of researchers and forming the bedrock of study at European universities for hundreds of years.
Which brings us to a really fascinating question. How exactly does a 1,200-year-old methodology actually build the modern world? How do we bridge the gap between his ancient, fire-heated glass equipment and today's multi-million-dollar laboratories filled with powerful computers and sophisticated instruments?
Well, the answer is right here. Observe carefully, experiment repeatedly, follow the evidence. The technology has definitely evolved. Entire empires have completely disappeared. Centuries have passed. But the core principle, the very soul of scientific inquiry that Jabir championed, remains exactly the same. Every new chemical breakthrough, every single life-saving medicine, and every discovery about the matter that makes up our universe, it all owes a debt to this remarkable scholar. Jabir didn't just study chemistry. He created the very framework for it to exist. So the next time you take an aspirin or even just drink a glass of filtered water, ask yourself, what other modern miracles are hiding in the pages of ancient history, just waiting for someone to translate them? Keep following the evidence, and we'll see you in the next explainer.